May I request all the speakers to kindly join. We'll also put on the video for a while. So good morning, everyone.
Good morning.
So on behalf of Indian Chamber of Commerce, I would like to welcome you all to the fourth edition of the Cementing India Conference. Because of the ongoing pandemic, we have to organize it in the e-mode once again. So I would like to welcome on board Mr. Yashwant Mishra, President Corporate and Chief Financial Officer of Mangaram Cement. I would also like to welcome Mr. Srinath Savud, Joint President of Shree Cement Limited, and Mr. Hakimuddin Ali, Executive Director and ExCom member of Dalmia Cement Limited. India's growing infrastructure is the backbone of its economic prosperity. It does, however, result in extremely high emissions. Whether it's the fugitive dust that frees construction sites, cement burning, carbon emissions, and excessive power usage, or the millions of tons of rubbish left every year. India's construction boom has a negative impact on the country's ecology. Cement manufacturing accounts for about 6% of all the CO2 emissions. Despite the fact that the cement industry is still in its early stages of digital transformation, there is a growing interest in the role that digital tools could play in speeding up deep decarbonization. With this backdrop, we are organizing this initiative, and we have experts from the sector who will further elaborate on the subject. And now I would request Mr. Yashwant Mishra, President, Corporate and Chief Financial Officer of Mangaram Cement, to kindly address us.
Thank you, Niranjan.
Thank you.
Good morning to
Over
all.
to you, sir.
Friends, ladies and gentlemen, as Niranjan has correctly said that the industry is at the initial stage of digitalization. We agree. Lots of opportunities are there, and in this era of digitalization, cement industry shall be one industry where digitalization can be at the maximum level. The cement industry has been categorized as laggards when it comes to the adoption of digital technologies. But the benefits of digital technologies, including revenue and other margin impacting factors, are compelling the industry to consider harnessing the power of digital technology more seriously. Yes. You see, in the 3rd century BC, the Romans developed concrete for use in construction. But see the difference, while Portland cement was first introduced in the 19th century. So we can see from 3rd century to 19th century took a long time. The combination of industrial processes, automation, and the emerging field of industrial chemistry vastly improved production and product quality also. However, in terms of environmental impact, cement manufacturing is energy intensive, and it is estimated that Portland cement is responsible for 7% of the world's carbon emissions.
Mr. Mishra, sorry to interrupt. Mr. Mishra, yeah, your voice is not properly audible.
Process.
Mr. Mishra, can you hear us?
While reducing cement in
Mr. Mishra, you are not properly audible.
Mr. Mishra, your band is showing low on your mobile. Please switch up your video and speak, please.
New digital journeys. As we all know, the cement industry is one of the building blocks of economic development. However, due to the recent pandemic, COVID-19, okay. Is it audible now?
Mr. Mishra, you put off the video and then you can carry on. Otherwise, your bandwidth is low.
Of my
You can
video.
keep the video off. Yeah. Now it is better. Now you can.
Now, voice you can hear.
Yeah. Much better. Please carry on. Thank you.
Thank you very much. Thank you. Let me continue. Sorry. I was just speaking. As we all know, the cement industry is one of the building blocks of economic development. However, due to the recent pandemic COVID-19 outbreak, the construction activities have slowed down everywhere. Hence, the industry is witnessing lower demands leading to overcapacity. Let us understand the key challenges of the cement industry and analyze how specific technologies can help. Data is the foundation of every digital initiative. Most cement companies have huge repositories of data, but lack the analytical capability to seek qualitative insights. The capability to analyze data quickly and take timely decisions is crucial in an era where demand-supply situations vary frequently. As per McKinsey report titled The 21st Century Cement Plant, Greener and More Connected, pursuing digitization means advanced analytics, process digitization and automation and robotics can boost the productivity and efficiency of a typical cement plant and result in a margin gain of in Indian rupees 300 to 7 rupees per ton of cement. Most cement manufacturers have plants that are really old and have commissioned for a long period, especially in India. Typically, experienced plant engineers who used to run these plants earlier are still using the same controls to run these plants. The data created by DCS SCADA systems can be utilized for analytics using artificial intelligence technologies to identify any fluctuations and variations in the process and fixing the same at the initial level, thereby achieving business benefits without any capex. Being a capital intensive industry, cement manufacturers invest heavily into high value assets, which typically run on 24 by 7 basis. There is an immense need to improve the utilization of such assets. These assets operate in harsh environments to ensure continuous operations and workforce safety. These assets are maintained for increased usage and parts like bearings and couplings are replaced frequently. Thus, by monitoring and analyzing combinations of vibration, acoustics, and temperature, by using latest sensor and hardware technology, the manufacturers can decrease plant maintenance and spares costs and increase assets availability and performance. Today, the technology to effectively collect and analyze data is readily available for cement manufacturers. It is now time to act on rich repositories of data that they already have and convert it into insights that is required for improving customer satisfaction and profitability. The core process of the industry involves the physical extraction or handling of materials. I say the usage of intelligent automation will be better deployed towards processes, re-engineering, and sustainable productivity. In the cement and mining industry, digital transformation refers to a lot of initiatives and technologies that reduces time spent, lowers cost of production, and enhances production efficiency. Top leadership can view intelligent dashboards that give an insight into the state of the business. The supply chain can undergo transformation to give every player a bird's eye view into the logistics network, or financial managers can leverage automation to divide resources more efficiently. One of the key objectives of automation is to reduce physical risk also. Through sensing and computing technologies, the industry can thus create a safer environment. Mining automation thus covers a broad spectrum of activities that help create a risk-free and effective operational structure. Be it through equipment, software, or communication technology, automation is now changing the game for the cement and mining industry. The use of digital technology such as advanced process control can further improve energy efficiency by as much as 5% plus. A final aspect of optimizing energy consumption is the application of digital technologies that enable advances in feed, material and product quality control, as well as process operating control. Digital connectivity also enables remote or online support services or condition monitoring that can enable both processes and mechanical benefits. You see, there is a big change in the RMC sector of the industry also. RMC sector has saw seen increased level of automation in last few years. Maximum RMC players have adapted themselves to digitized process and automated plants. The automation in RMC sector has reached such a level that a person sitting at home can do the batching at the factory or from any place in the country to any other remote place in the country. A person can operate more than one plant sitting remotely also. Few examples of the automation can be summarized like artificial intelligence can predict new project demand, overall supply network optimization through improved association of queries and plans, stock optimization and RFID typing of raw materials. Digital twin is also in use at some places. Might not be in India, it is not in practice, but in foreign countries, especially in Europe, it is gaining importance and is being used in cement industry also slowly. Quality prediction can be done. Robotics, cobotics to perform tasks under heavy pressure and high heat. Soft sensors and variable sensors for closer monitoring of processes and safety. Augment reality to support warehouse activities and loading. AI software now allows such systems to learn and improve with each experience. As the machine learns, it can make data-driven predictions without being reprogrammed. Every cement plant today monitors the manufacturing process from several control rooms, and all adjustments and decisions are taken by the people in the control rooms as they react to changes in machine and process variables. While in contrast, the ICT, Integrated Control Tower, which is being used by many cement plants in India, employs scenario software to productively run the process as closely to the desired ideal as possible. Gist is that using this digitalization platform proactively and at the best level, there shall be improved efficiency in cement plants, especially at this time when cost of input is very high and day-to-day energy efficiency has to be done because cost of coal, pet coke, whoever using in the cement plants are at the highest level since inception. We have never seen that pet coke or coal is being sold at 20,000 rupees per ton, but people are using still and they don't have a choice. So energy efficiency can be brought by this digitalization at the best level, and there can be a saving of more than 5 to 7% immediately. I hope I have tried to make some importance of the digitalization in cement industry before you. Thank you very much. Thank you.
Thank you so much, Mr. Mishra. It was really wonderful listening to you. It was really so informative. And now I would request our next speaker, Mr. Srinath Savur, who is the Joint President and Chief Sustainability Officer of Shree Cement Limited, to kindly address the audience.
Yeah, thank you, Nilanjan. Ladies and gentlemen, I thank the organizers for giving me this opportunity to present my views. I'm going to be talking about climate finance. Climate finance has been a hot topic in COP26, and I'm going to talk about why it is so important for Indian cement industry. I'm also going to try and put some light on what kind of money we are talking about and conditions which would require to be met in order to for industry to be able to use this climate finance. So we see climate change in everyday life by way of extreme weather events. We have seen intense heat waves, intense cold waves. We have seen erratic monsoons. Even as I speak, large parts of southern India is seeing unseasonal heavy rains. We are seeing various other such events, and the frequency of these extreme weather events is going to go up. The recent report, which was released by IPCC, paints a very grim picture. It talks about rising sea levels. It puts entire countries at risk. There are these Caribbean islands and many other island countries which are likely to be inundated by the year 2100. In India, our coastal cities like Mumbai, Chennai are in real danger. So something really needs to be done, and bold and decisive action is needed. On the other hand, India has development needs. We have a large mass of poverty which needs to be lifted, a large mass of population which is below the poverty line, and these need to be lifted up. The recent COVID crisis has made things worse, and a lot of people on the margins have been pushed below the poverty line. And many economic activities which would be required to lift up these people would necessarily lead to emissions. Now, the cement industry is somewhere in the middle of this conundrum. So, on one hand, cement industry is a large emitter of greenhouse gases. As Nilanjan mentioned, approximately 6% of the GHG emissions come from cement industry, and India has the second largest cement industry in the world. So necessarily, Indian cement industry would play a major role in combating any kind of climate change. Indian cement industry has done quite a bit in has made several attempts, and ongoing attempts are being made to contain the carbon footprint. Almost all large major cement industries covering more than 50% of the capacity have committed to bringing down their emissions by the year 2030 under the Science-Based Technology Target Initiative, SBTI. And under the aegis of GCCA, most of these industries would also aim at net zero by 2050. Now, the strategies that are being used by the Indian industry are basically threefold. Firstly, there is energy conservation. A lot of work has gone into energy conservation, and a lot of it has borne fruit. As my preceding speaker said, there is attempts at digitalization also, and large companies, including mine, are actively pursuing this strategy to bring down energy conservation. India is definitely ahead of the curve as far as energy consumption is concerned, as compared to the world. We have some of the state-of-the-art plants, and some of the most efficient plants in the world are in India. And this has been borne out by a lot of studies which have taken place. I remember a CSE study which had taken place some time back. It was brought out by one Mr. Chandrabhushan, who is no longer with CSE, but he is still a very active, activist in this area. It put India at one of the most leading, energy in the energy field. So energy conservation is the first step. And then we have blended cement. Blended cement means that from the same amount of clinker, you make more cement. So blended cement percentage is quite high in India, again, as compared to the rest of the world. The third is alternative fuels, which would also tend to bring down emissions, because many of these fuels would not contain any carbonates, and there would not be any release of CO2 in the atmosphere, apart from what goes in the burning process. So these are three major strategies which are being pursued by Indian cement industry. However, there are limitations. Indian cement industry, as I said, has already done a lot in energy conservation. So any gains from here on are going to be incremental. There cannot be a very large gain in energy from the present level. In terms of the blending materials, the most commonly used blending material is fly ash, and the changing energy mix of India, where the role of renewables goes up, would result in a lower availability of fly ash in the future. Our Honorable Prime Minister has recently in the COP26 made an announcement of reaching 450 gigawatt of renewable capacity by the year 2030. And definitely by that time, the role of thermal capacity would come down. And so hence the availability of fly ash. Again, as far as AFR is concerned, there is a limit beyond which you cannot use AFR. So there are limitations in the present strategies. In any case, all these strategies would only lead to carbon reduction, not carbon elimination. For carbon elimination, we need two things. Firstly, the fossil fuels need to be replaced. But even if they are completely replaced, there will be still CO2 released because of the embedded CO2 in the in limestone. Limestone is calcium carbonate, and when it is calcined, it releases CO2 during the clinkerization process. So we need something like carbon capture and utilization. Now, all these technologies are at a very nascent stage and are not capable of being deployed on a commercial scale. But a lot of work is going. And I'm quite confident that over the next decade or so, there will be developments and advancements which will enable the cement industry to use these technologies. But to use these technologies, we need huge amount of funding. The cement consumption in the last year is estimated to be 350 million tons. Over the next 10 years, assuming a growth rate of 6 to 7%, they would be roughly double. The consumption would roughly double to between 650 to 700 million tons. The corresponding clinker capacity would be around 500 million tons. At current costs, if we assume that the cost of setting up cement capacity is around $100 million per ton, we can roughly estimate that even if we need $20 per ton of clinker capacity to deploy this technology, and we have been in touch with a number of manufacturers, and they are quoting something like 60 euros per ton of clinker, but it will come down definitely. So I'm assuming $20 per ton. Then we are talking about $10 billion, which is a huge amount of money. Now, where does this money come from? It has to necessarily come from sources which are not at commercial terms, which eventually means the developed countries will have to finance the developing countries, especially for adaptation kind of utilization. Because when we are talking about retrofitting existing equipment, it is adaptation of existing capacity for eliminating the carbon footprint. One other thing which is important is that there would be a time when both green cement and conventional cement would run side by side. Now, it is my belief that nobody would pay extra for green cement. So it has to be at par with conventional cement in order to compete in the market. So, for instance, I mean, would you pay higher cost for power only because it is produced from renewables? I don't think there would be many consumers who would be willing to do that. So the same applies to cement. So cement has to, if it has to be at par with conventional cement, green cement has to be at par with conventional cement, then all this financing which comes has to be at very soft terms. Now, and I'm not even talking about additional capacity. That in any case would be at whatever terms are decided. But at least for retrofitting, it has to be at very, very, very soft terms. And we are talking about huge amount of money. So there is CapEx support which is required by way of soft financing. There is also, in order to maintain parity, there would have to be some kind of policy support from the government, but either by way of imposing carbon tax on conventional cement or giving tax rebates. For instance, lower GST on for green cement. It could be much less than the 28% that is the GST rate currently. It could be, ideally, it could be 0%. That gives a certain amount of leeway to for producers to make green cement. Therefore, for abatement, we need firstly technological advancement, which I'm sure would happen. We only have to look at solar. Solar, 10 years back, the cost of putting up a solar plant was around 14 crores per megawatt, 10 to 14 crores per megawatt. Today, it is at par with thermal capacity. And that's the reason why we see such low ports for solar energy. So, technological advancement would be required, but climate finance would also be required in large quantities. Let us now look at some developments in climate finance. The 100 billion tons, $100 billion, which was promised by developed countries to developing countries, which was first, in fact, conceived in 2009 and then endorsed in the Paris Agreement of 2015, has not been seen. The highest, I think, which was seen was in 2018, which was around $70 billion. And so developed countries have fallen short of the target set in this, this agreement. OECD's projections after the COP26 suggest that climate finance will reach around 100 billion tons, $100 billion into the 2023, but details are very opaque. No country by country quotas or amounts are set out. There is no clear indication of which international organization will increase their contribution. There have been several developments. Several European countries such as Italy, Netherlands, Norway, Spain, and Sweden have made new pledges, which are in excess of $500 million. But these are going up to 2025. The US has increased its pledge to $11.4 billion, which falls far short of the fair share that should have been there based on its per capita emissions. Germany has emerged as a real leader with $6 billion per year commitment, along with real increases in concessional finance over the past decade. There are some positive developments. The commitments from the US are additional. They are not reallocations of existing development aid. So they are actual increases. Several countries like Canada, Denmark, and Finland are increasing allocation to adaptation. And this is important because, as I said, adaptation finance is critical since it will not lead to any new revenue stream. And it would have to be serviced within the normal revenue stream. Our Honorable PM has linked India's pledge on emission reduction to receipt of $1 trillion. And let's hope some of it flows to the cement industry as well in India. To conclude, huge amount of funding would be required for combating climate change. The money should be given for adaptation as well as mitigation, not only for mitigation. Currently, most money that is coming in is for mitigation and most of it is going into renewables. Money would be therefore required as grants or concessional finance. And so it would largely have to come from the developed world. Thank you.
Thank you so much, Mr. Savur, for giving us a view of such a holistic and realistic view of the sector. And now I would request Mr. Hakimuddin Ali, Executive Director and ex-com member, Dalmia Cement Limited, to kindly address.
Very good morning, everybody.
Good
First
morning.
of all, my thanks to Mr. Nilanjan for inviting me for this seminar and sharing my thoughts. And my heartiest greetings and best wishes to Mr. Mishra, Mr. Shaur. It's always tough to speak last because whatever you thought that you would like to touch upon is mostly spoken about. But so the challenge is now that if I can make it still interesting and more unique and slightly drill down more. I think there is no other better starting point than COP26, which recently was done in Glasgow. I'm very happy to share that from India, the only industry leader who was invited there was Dalmia Cement CEO, Mr. Mayan Singhi, who represented the country and the cement industry as well. I think this was an honor for us. And what transpired there, of course, cement and steel being the two highly polluting industries, we already talked about it, contributing about 5%. Cement only contributes 5% of the total CO2 gases globally. And the more serious part here is that every ton of clinker that produces about 900 kg to 1 ton of CO2, which is, if you look at the current production capacity, say clinkerization capacity in India will be around 300 million ton, and the full cement capacity is about 400 million ton. So the kind of CO2 gases that we are generating today is seriously massive. And now the time has come, and all the global targets that were taken, especially in COP26, despite 63 countries committing to it, there is still not major progress. What is expected is that there will still be a rise of about 1.8 to 2 degrees centigrade above the pre-industrialized area, whereas the target was to bring it down by 1.5 degree. Our Prime Minister committed by 2070 will be carbon neutral. Probably this is the date which is the longest date for any country to mention, but it is natural for us because India has just started growing. With the kind of population that we have, we can't commit, whereas the already industrialized nations need to actually further their or prepone their dates of commitment. With this context, if the cement industry is to grow at the rate that we're talking about, of course, from per capita consumption of 235 with the advanced per capita consumption of around 520, there is a substantial growth possibility. India needs to grow, and that's where the challenge lies, that how do we combine this growth with actually balancing out the CO2 emissions. So now I would be slightly differing here. It's not going to be only digital technology. It's not going to be only automation, which is going to bring this turnaround, because all those work which was supposed to be done and leveraged by using these technologies have been done in last 15-20 years substantially in cement industry, which has brought about 8-10% of savings. And it was primarily from the perspective of cost. It was never from the perspective of CO2 reduction. And that's where I would like to highlight 6 or 7 points and measures. So Dalmia Cement committed for being carbon neutral in 2040. And there are initiatives which we have already extended in place. And the way we want to actually chart this course, unless we have a course in place, we will not be able to correct. And by doing, minor tweaking, it is not going to happen. So what are these major 6 or 7? As just mentioned by Saurji, I think the major part of CO2 emission comes from the calcination process in the cement industry, which is almost 40% of the total or 50% of the total CO2 generated is because of that. I think the first and foremost initiative that we across the companies are taking is to reduce the fossil fuel. And I think it's high time now that we have to really very swiftly move to all sort of alternative fuels, which includes, recycled plastics, it includes municipal waste, it includes biomass, it includes, bamboo chips and all kinds of things, and including hazardous waste. Now, the crux lies here is that for being able to use these fuels and using it efficiently, we need a lot of capital cost in the plant itself. So inherently, Mr. Saul just pointed out, the capital cost of the plant goes up substantially. For a normal green fuel usage, you need to spend at least 20 to 30 crores of capex. But for being able to use more hazardous fuels, we will need at least 50 to 75 crores of capex for chlorine bypass and those kinds of systems which needs. So it's almost in the tune of 100 crores that you need to spend additionally for these things, and it has to justify the investment. But if we only see it from the cost and return perspective, it will not always be the best ways to do it. And that's where, inherent mindset is required here to change the way we work in the entire cement industry. And this should become, like in earlier times, ESPs and back filters became normal part of the system. All these things have to become part of the system. Coming to the second most critical part is the power plant. So many cement plants have their own captive power plants, and about 30 to 40% of the greenhouse gases is actually because of the power plants, which is being used for manufacturing electricity for producing cement. And that's where another major this thing is to use alternative fuels, and biomass is another major substitute, and using high efficiency boilers. I think this is another technology change which is coming up very fast, using high efficiency turbines, which also brings in additional capex. So on an average, it will be a substantially high capex. On a plant of a 3 million ton capacity, there will be at least 250 to 300 crores of additional capex which may be required for doing this kind of investment. Coming to the third and the easiest one route, which already has been initiated. So for example, Dalmia has already initiated the solar power route, and we are already working on about 30 megawatt of solar power, typically 8 to 10, 7 to 8 megawatt for each site, so that we try and become 30 to 40% of our energy source should come from the solar route. I think that's the third and very critical part. Even if the cost of capital is same as thermal, still this route is usable and should be pursued by the industry. The most critical area where 10% of the carbon footprint is there is the logistics in cement industry. And this is where I would say the digitization part and the digital initiatives that we are talking about will be most successful. And I think many companies have already started this. The most critical part, and there are two enablers here. The first enabler is to optimize your routes. So if the trucks have to move 100 kilometers, how can you ensure that it only moves 60 kilometers, so you can actually save that much of fuel and that much of generation? And this is happening now by way of very strong digital tracking, ensuring that there are direct deliveries and dispatches. Earlier, I would say in earlier times, it used to be already 2 or 3 dumps. So you send it to the godown, then godown sends it to sub godown, and sub godown sends it to the customer, and the material actually moves erratically. Today, because of the digitization, what is now happening, since you are able to track the customer and the trucks accurately, we are now attempting 70% direct dispatches. If we are able to do 70% direct dispatches, it not only brings down the cost of your logistics, but most importantly, it brings down the carbon footprint. And that's where I think everybody is now working towards. And this is very big enabler and lever for the cement industry. There are one important lever which Mr. Saul also pointed out, and I would like to further reinforce that pushing the usage of blended cement. I will say it to the extent that it is actually criminal today to use a OPC. Whereas it is very unfortunate that the largest consumer of OPC is the government today. It's so unfortunate that despite so much of progress in cement technology, despite so many representations by the industry to the government, they have not been able to change the specifications. They have allowed to use PPC or slag cements and others, but they still are prioritizing on OPC usage, and for some fancy reasons. To be very frank, I think there are now no major technical reasons why we should not shift from OPC to PPC and others. There is, I will go on to say that there are inherent financial advantages to a lot of builders, because irrespective of whatever, they are now mixing fly ash in a very nonsensical way on roads. And this creates enormous problems for the industry itself and for the roads that we are constructing today. So I think pushing the blended cement, and why I'm saying so, it consumes 30% less clinker. If you consume 30 to 35% less clinker, it is a direct implication that you are actually bringing down the CO2 gases by 30 to 35%, because you are not using higher generating product there, and you are also solving a major problem which is currently from the power plants. Mr. Saur just pointed out that because the Prime Minister has mentioned about 450, 500 gigawatt through alternative resources, so there will be less availability of fly ash. I would like to say that there is no reduction of thermal power plant which is happening. It is just that the growth is being captured by the alternative resources. So even if the power plants, thermal power plants grow at this rate, the rate at which they are generating fly ash is far, far, far higher compared to what cement industry or any other industry can consume. It's already a huge mess, and there is a policy required there by the government to subsidize and to provide fly ash to the industry so that it can use it efficiently. Today, the logistics cost itself is so high that it can be used only in minor percentages. And that's where I think for both slag and fly ash, there is a separate policy generation which is required. Coming to the efficiency measures and where the digital things have happened and already happening, I would say there are 4 or 5 initiatives. Waste heat recovery systems again have become a must. We are investing already in our new plants, almost 150 crores per plant for generation of WHRS, because every ton of coal that we burn should be used for its energy. And that is where WHRS actually brings in substantial benefits. And that 100 to 150 degrees centigrade of thermal energy, which is being let out by the stack, can be captured and used for production of energy. And then there are VFDs, there are green buildings within the plant. I think all those initiatives are going to help, which is already helping us substantially. Last but not least, I will say that cement industry touches the lives of many, many end users and consumers. It also touches the lives of its employees and stakeholders. And that is where a propagation of lesser carbon footprint is important. And so electric vehicles in usage and shifting of logistics, where I missed out that point, that apart from optimizing, we also need to promote usage of electric vehicles in shifting of inbound raw materials and outbound raw materials to the best possibility. And that technology is developing. I think it will come very soon. It will bring down the carbon footprint substantially. Also, we should promote usage of electric vehicles with our employees and stakeholders and end customers as well. And that's where responsible selling should start happening. And green cement today has become a thing to work for. So green cement is something which is where Dalmia Cement is pushing hard. We are trying to generate a large amount of curiosity in usage. Unless we make people conscious, we make our consumers conscious, we will not be able to win this battle. On this front, on this 6 or 7 points that we are working on to make us carbon neutral, I would like to close with this line that we have already reached about 490, 490, 500 kg per ton of cement of CO2 generation, which is already 40% lower compared to other plants. And our target is how we can bring it down to zero. It's a very, very large milestone. It's a very big river to cross. But I'm sure, I think the collaboration of cement plants can lead us to that direction. So with these words, I would now leave it to the audience on some of the thoughts that we have put on table. And I also thank my previous speakers for highlighting on this topic. Thank you very much.
Thank you so much, Mr. Ali. It was a pleasure hearing you. I think all the audience have really benefited out of it. Now we'll take up some questions, which I find in the chat box. Mr. Sanjay Nandi, he has asked, what would be the volume outlook expected for the second half, and also the current scenario post H1 for 2022 to 2022. I request any one of you to kindly take this up.
I can.
Anyone is speaking?
Yes, Mishra sir, please.
Yeah. You see, first half till September, the volume outlook was better, except the month of April, because that was hit by the pandemic. But now we believe that after this festival season has gone up and government is taking so much of initiative, especially in infrastructure, and housing sector has also started moving northwards. The outlook for cement volume is better in the second half, and we feel that in next year the volume of cement shall be much better. Yes, but we cannot expect more than 75% for this year. I think overall utilization, if 75% happens, it shall be much better for all the cement industry as well as the consumers, the associated related dealers, promoters, everybody. But the government is committed, and that they have building so much work on infrastructure at all places, more or less in the country. especially where cement plants are not there and where cement plants are there. It will give a boost to the cement industry as well as to the work also. Thank you very much.
Thank you so much, Mr. Mishra. It was really taken well. And there's one more question that's not very clear. Mr. Nomu Shankar Shetty, he's asking that he would like to take up government construction contracts, BTS, through cement. So what is the way out?
I don't think that is a question meant for this, this
Yes,
gathering.
it's not a okay, okay.
Yeah.
We will take a last question from Mr. Sudhanshu. He has asked, could you please educate us about your proposed demonstration plant at Tamil Nadu for CCU?
I'm not sure to whom this question is.
Yeah, it is meant for you, Mr. Ali, because you are the only company which has a demonstration plant, I think.
Okay. No, so no, I didn't understand the question. If it can be elaborated properly. So
Yeah, he's asking that could you please educate us about your proposed demonstration plant at Tamil Nadu?
So very honestly, I am not aware about this topic, so I may not be able to answer it right now, but I will surely come back to you on this. Because southern region is handled separately, but I will surely come back if at all I can come back to us.
Sure, sure. So you can write back to us and then we can coordinate with him. So there's no more question. I think whatever has been discussed, all the questions are answered in prior. So it gives me real pleasure to deliver the closing remarks and the formal vote of thanks. I express my deepest appreciation to Mr. Srinath Savur, Mr. Hakimuddin Ali.
How can you speak? He has already given a vote of thanks. You don't understand English?
Hello. Hello. Is anyone speaking?
Hello?
Yeah. Hello.
Hello?
Yes.
I'm Sudhanshu Chakraborty is still calling.
Tell me, Mr. Sudhanshu.
I'm representing India for the decarbonization, particularly in cement industry. I'm nominated through Indian National Academy of Engineering. There in the Council of Academies, I told them that they are making all the demonstration plan because Mr. Singhi told it in global conference and it is also written in your annual report. And he claims that this is the only plant in the whole world which is coming as a demonstration plant. And he got a lot of claps. So I'm surprised that you are not aware of it being in that industry and you talk so much about Dalmia cement. Because that is the only clap Dalmia cement got it.
So I would be extremely sorry for that because we can always this thing. But so are you talking about that 1 million ton plant in that has recently 10,000 TPD plant which has been recently done in Trichy, which you are talking of which demonstration?
Not a plant has yet been done. It is being proposed.
Okay.
Because you must appreciate whatever you may talk or you can do, there is no option other than carbon capture use and or storage. Okay. And Dalmia has claimed that they are going to be the first demonstration plant in the world, even in defiance of the plant which we are having in Heidelberg or in Switzerland, in Norway, etc., etc. I'm fully familiar.
Right.
They asked me this question after Singhi's speech that do you know what this plant is being done and details of it? It is in association with this clean energy solution of UK. It is a patented one. So I fully appreciate that it cannot be disclosed the detail, but at least you could outline it.
No, I will surely. As I said, there is no crime in ignorant about something.
You told so many things about that 100 crore, 300 crore and 500 crore investment and the commitment that in 2040 and your commitment is the zero emission in 2050. If you could publicly announce those things, which is also in your annual report, then why couldn't you tell what that demonstration plant will do, what is its capacity, and how it is going to capture the carbon, and how it is going to be utilized, because it is going to be in some liquefaction form, and you are shipping it and for the various uses of the industry.
Exactly. So I am only saying that yes, carbon capturing technology is a very new technology. Mr. Singhi has announced it. I am not aware about details. It's not that I am not speaking about it because there is some confidentiality about it. I'm only saying that I am not aware of it, and there is no crime in being ignorant about some topic. It's a large organization. Sometimes it does happen that we are not aware about something, because we are focused on this part of the world. But I will surely come back to you with more information on it, and I can send it to Mr. Nilanjan Chaudhary in a written format, maybe by end of the day today. So I sincerely apologize for not being aware of that topic.
Mr. Sudhanshu, I think Mr. Ali has already answered your question, and we will take it up offline. That's not an issue. So, as we come to the close of the session, I would once again like to thank all our senior speakers, Mr. Srinath Savur, Mr. Hakimuddin Ali, and Mr. Yashwant Mishra. I think all the topics were dealt very well, and all the questions were also answered. I would like to thank our friends from media for being with us in this session. I would also like to thank all our participants and our sponsors for supporting us all throughout. A special thanks goes to Sri Cement Limited, JK Lakshmi Cement, Max Cement, JSW, and WBSEDCL for supporting this initiative. Now we'll go to the next session, which is on Beyond the Headwinds for the Cement Industry. I would request all the speakers to kindly join the session. I think they've almost joined.
Thank you very much. Thank you, Mr.
I will request Mr. S.K. Sadhu, Senior Advisor, Consultivo, Mr. Shubhajit Banerjee, Assistant Manager, Nuvoco, Mr. Ajit Kumar Paul, Assistant Vice President, Ramco Siemens, and Mr. D.S. Malik, Director and HOD, Mechanical of BCPL. Kindly join the session. A special thanks goes to Mr. Sadhu for joining us all the way from US. So it's midnight over there, but he still found some time to remain awake to address us. Thank you, Mr. Sadhu. So since I will be moderating the session now, I will request you to start with you. Mr. Sadhu. Mr. Sadhu, can you hear us?
Audible?
Yeah. Yes, you're audible, Mr. Sadhu.
Yes.
Please carry on.
Yeah. Thank you, Mr. Chaudhary. And we just had the first session. We'd also like to convey our appreciation for a good first session. Our fellow panelists, Mr. Ajit Pal, Mr. Shubhajit Banerjee, Mr. Malik, and all the officials for Indian Chamber of Commerce. My first presentation is on post-COVID-19 opportunities in the cement industry. In fact, on this, there have been some discussions already. I would like to very shortly elaborate few points. Yeah. Can you please share the document?
Yeah, I'm just.
Yeah. Post-COVID-19 opportunities in cement industries. Yes. Next. This is about a small brief about the Consultivo organization, who are on consulting, training, research and analysis, and training. Next. This is my short introduction. We'll go back to the subject immediately. Next. Yes. Next. See, there are several factors which have been influencing cement industries. Vaccination, positive impact on volume, not very positive, fluctuating. Margin and cost realization, again, it was quite adverse. Energy and transportation cost, adverse, it has gone up. Administrative overhead, of course, administrative overhead in several ways, in several areas have been reduced. Employment scenario and labor market, as already everyone knows, there has been impact on the employment scenario, availability of labor, as well as the labor market. Online operations, it has substantially gone up. Environment challenges, that is going to come in a big way for the cement industries. Very elaborately, it was spoken in the previous session. Next. I'll just sum them up in triple P approach: production, productivity, planet, and people. Next. Production and productivity. Volume growth expected on positive note in financial year 21 and 22, but it was not consistent and lower than the pre-COVID projection. And that is going to, in future, our volume growth cannot be expected to go up as we had earlier. The action demanding focused attention on this production productivity is plant capacity utilization. I mean that in the rate at which cement plant expansion have been going on, new plant expansion, probably much more thrust will have to be given about the capacity utilization of the plant. Plant modernization, replacement, and renovation. Most of the old plant and plant will have to be renovated. Replacement and new plant, if it has to come, then it has to be a very modernized plant, and a lot of renovation will have to be done. Mechanized operations in every sector. Mechanized operation will play a very important role, and particularly in logistics and apart from some of the operations area. Improve logistics and distribution. Improve operational efficiency through AI, digital technology in various operations. In fact, cement industry had been doing a lot on the digital, on the process automation, and it has gone up. But in the coming year, probably a much more thrust will have to be given on this digital technology in various operations. And because of that, our investment in IT infrastructure will have to be more. Next. Plant sustainability initiative. Here, the focused attention to reduce carbon footprints. As already said that almost 5% of the total pollution is by cement industries, and to reduce the carbon footprint, multiple actions are going on globally, and we have our important steps in the industry, in Indian scenario also. So maximize TSR, thermal substitution rate, and our TSR is quite low compared to the world average, global average, but there are ambitious targets with the industries. So here the maximum attention will have to be given. Maximize AFR utilization, waste heat boilers, and as already spoken in the previous session, high efficiency boiler and turbine will have to be used. There should be more use of biomass, solar in the to save power. Minimize coal-based captive power plant and power from the grid. R&D, pilot plant, adoption of low carbon technologies will have to be given thought of, even implemented. Carbon capture and storage, though they are the very nascent stage, but in future, if you look into the prospect and the very ambitious target that Indian cement industry have pledged that they would like to become carbon neutral probably by year 1970, then carbon capture storage, concrete recycling, carbon absorption in concrete. These are some of the very important areas which in the coming decades and all will have to be, we'll hear more and more about it, and that is going to play a major role. Development of substitute materials for cement and clinker, that also is another area. Next. And third is people. Of course, we have to think of the people. So focused attention on people front affected adversely on income generation. What we need to do also here, now skill development on direct and indirect workforce, including outsourced departmental, will have to be given a much greater attention. In fact, we have been, our cement industries, mostly were taking care about the skill development for their own staff, but now we have to go beyond that. Outsourced, like those who are dealing with the construction, contract work, or vendors and other areas, we'll have to include all of them in the workforce so that whatever output we get is more efficient. Health and safety programs and training, that also will have to be covered to all, not only employees and our own workforce, but all allied services and indirect. Job enrichment plan, especially for managerial section. So managerial section also may have to be given scope for job enrichment, like their exposure to IT industries and IT infrastructure. And then we have to give much greater thrust on community development, on strategic areas to improve income generation, health and education. These are the some of the interest in future. The cement industry will have much more responsibility and scope also for overall improvement. I think this is not in a nutshell. I've tried to figure out some of the opportunities area. There may be several more opportunities also, but there are some factors which can be given out. So I would like to thank ICC for giving me that scope to share my thoughts to you. Thank you.
Rather, we would like to thank you, Mr. Sadhu, for being so cooperative and being a guide to ICC from the very beginning. Thank you for once again for joining all the way from US. And now I will request Mr. Shubhajit Banerjee, Assistant General Manager, Nuvoco Cements, for his address. Mr. Banerjee.
Good afternoon,
Good
sir.
afternoon.
Am I audible?
Yeah. Yes, you are. Please carry on.
The presentation is already sent to ICC. I think you will share that, or I have to share my own?
Sir, please share yourself, sir.
Yes, sir. That will be better because your file is quite big. It is taking time to download.
Okay.
You have been given the sharing rights. You can share. Thank you.
Making you presenter, sir. Just a minute.
Yeah, Debu, please do it immediately.
Yes, sir.
Thank you. Is it visible?
No, sir, still not visible. You just share from the share and open that PPT, sir. Yes, sir. It is showing.
Yeah, it's clearly visible now. Yeah, you can continue.
Clearly visible. Okay. Good afternoon to all the seniors, and very thank you to ICC also to give me a chance. Thanks to Sadhu sir also. He thinks that I can be a speaker of this forum. The main topics of today's discussion was the challenges of cement as product during COVID and the customer centricity, what the companies are doing in cement industries mainly. First of all, I would like to introduce myself. I am Shubhajit Banerjee. I'm basically a chemical engineer, and I was with the cement industry since last 16 years, and I'm in the production and quality field. I'm looking after the complete operations of production units of West Bengal. So the first in during 20.
You are not audible, Mr. Banerjee. Can't hear you. Mr. Banerjee, we can't hear you.
Really now it's at 50-55% level, which was earlier at 85% level only. And major the problem is the funds are also not rotating. The dealers' credit period has also increased. So the people are not giving back to the society or giving back to the manufacturing industries. That's why maybe the in terms of trade market the values are high, but in infrastructural way now which is a challenge because the people are not going for the new construction and all. And we are also hopeful to the government also that the it will after 15th of December probably the situation will improve. As Sadhu sir also told that it will may not be the as 2018-19, but anyway it will improve from the current scenario. And the challenges of main the supply also the supply chains are also disturbed because some of the during the COVID period some of the zones are containment zone declared, some of the areas and high level of no entries were there. Some dealers are not able to open the shops. Sometime we have lost some of our dealers also because of the COVID situation. The drivers are also not available during the COVID period. They are also ran away from the market. And again, the restructuring of truck fleet, again, the complete setup is readiness is little bit of challenge for us. And another challenge was in the rail unloading is also disturbed because the majority of the unloading at different sidings are done by the people, but people are also in their home and the manpowers are also not available at that time. So the demand and supply from the plant are also challenged during the uh, last two session of COVID. The challenge of cost is also the bigger challenge for us now because the fuel rates are very high. So uh, as the rates are high, but the prices are not high. Even in the eastern zone, prices are declining, and the freights has increased. The raw material rates has increased, and to cope up with the change because it is not the raw materials are not a commodity that you go in the fine morning and find it from the market. So it is we had a booking of slags, fly ash from the different sources. During the force measure, we can manage, but after that we have to stop. So the inventory costs are also high because the material is stocking and going on. So a plant which has earlier have a stock of 30-40,000 tons of material is now currently at 2 lakh tons of material with the inventory. And the cost of quality is also high because of the expiry of the cement in the market, the raw material quality of and even in the silos also cements are getting the number of days are increasing the stocks levels. And in the user front, also the non-availability of workmen and the infrastructure growth was also slowed down. And people are retaining their money; they're not investing. So probably some challenges because of COVID. People are thinking that okay, it may not be the right time. And even if we all are finding that in the market because of the non-availability of the jobs, and a very high amount of people have lost their jobs, and so that's why the rates increase. And so people are also waiting when everything will be normalized, then we'll go for investment. But these are with the challenges, and product is being challenged because of the high turnaround ratios when we produce and when we sell. So the working capital has also increased, and companies have to pump the working capital more. There are the delays even sometimes with the payments and all. So similarly, the companies are getting the money delayed from the market. So vendors are also delayed. So these are the main challenges we found during the COVID situation. And how we overcome the challenges, the operational challenges. First of all, during COVID, we used to sanitize the complete plant with a regular interval. Even the trucks, tires, the bulkers, the rail wagons, we used to sanitize. It was also a good practice from the plants. Most of the plants has done this type of job. But again, it's nothing is free in this world, so it comes with the cost. We have arranged the stays and food for the workers, and during the COVID time, because there are the restriction in the movement. The vaccination drive also done by the plants, even at our West Bengal Novo plants, we are now at around 97% of double dose vaccinated plant. All the workers, all the drivers, all the officers and staffs, those who are dedicated in nature, they are vaccinated with the second dose, and probably by 17th, 18th of December, we will be at 100% level. We have started the paperless job. The delivery orders, the challan, and all are now converted into the online system. And even when the material goes to the market, there's also an acknowledgement. These are also started. So, as this former speakers are telling, that the IT has now a major role, and they are in the front seat. So we are also changing according to the scenario, and digitalize the system. Even we are putting the RFIDs, complete tracking of the trucks, and all those are started. And the product challenge, we overcome through a improved quality of packaging, because anyway, which earlier the bags are sold out within a month time. Now it may be taken time of 1.5 months or 2 months. So we have to improve the packaging, because the quality has to be retained properly, whatever we delivered in the market. We have started go down deliveries. We have taken different go downs, because the majority of the evacuation is now at go down level. It also increases the cost and increases, but anyway, better the delivery in terms of market. So we stocked in different areas, and we thrust on the truck supply also, because after the standard loading come into picture at West Bengal, the trucks are also increases, and it is good for the industries. And also, so the people are now happy, because the freights and all those have slightly increased. So we have started the truck supply more. Rather, the wagons are also, because wagons were little bit of unavailability of wagons because of the coal and all. But now the challenges are overcome, and we are very much hopeful that in future days, the plant production and the challenges will be betterly welcomed and betterly managed, and we will go for a good production and all. So these are the challenges we faced during COVID, and what already speakers are telling, that the AFR, alternative materials, and all trials are going on to enrich the quality of the cement, to better the durability, better the packaging, and all. So we are hopeful. Thank you again. Thank you, ICC. Thank you, Sadhu sir, Ankita ma'am, Mr. Chaudhary, to give me the opportunity to share my thoughts. Thanks.
Thank you so much, Mr. Banerjee. It was really wonderful hearing you. It was really good to know how well you overcame all the challenges in the short period and set the ball rolling. And now I would request our next speaker, Mr. Ajit Kumar Paul, who is the AVP of Ramco Siemens, to kindly address. Mr. Paul?
Good morning to everybody. My name is Ajit Kumar Paul. I am AVP of Ramco Siemens. At present, I am in Odisha. I am the unit head of the plant. Can you display this my PPT?
Yes, sir. Yes, sir. We are doing that.
Yes, sir, I'm stating, sir.
Can you skip it? Next. Next. My topic is ongoing impact of COVID-19 in the cement industry. During this COVID era, in 2019 and 2019 to 2021, we have the industry faced a lot of problems due to the COVID. Mostly these supply chains disruptions, and due to the supply chains, raw material also got shortage because most of the plant was not in operation. Since the plant was not in operation, the plant could not utilize its capacity also. So underutilization of this capacity, that is also one of the impacts of COVID-19. Then due to this lockdown and all the issue, labor shortage also there, because most of the laborers, they left for their home, as there was not that much work over there due to this lockdown. And since lockdown persistent, demand also was very less. It is a weaker demand. Cement demand was not there. So industry faced a lot of cash flow problem also. So liquidity was a problem that time. And due to this lockdown, government also put some regulation which also slowed down the industry. So mainly this manufacturing industry was affected, raw material shortage, supply chain disruption, labor shortage, low scale operations, a negative impact on production volumes. These are the major impact due to this lockdown and this COVID. Next. This worldwide, what are the effect this impact on index for industrial production manufacturing before this COVID, that means 2017 2018, IPP was 4.6, and in 2018 and 2019 financial year it was 3.9%, and at the era of this COVID, that means 2019 and 2020, it started lowering down, that gone up to 1.4. And 2020 to 2001 financial year, it has gone minus 9.6. So it is a it is a very impact on the IPP. The complete lockdown and this partial lockdown, it affected much the limited movement of goods, services. Demand side also was not much. So ultimately this IPP has gone down 9.6, but at present it is improving and we expect that it will improve. Next. since cement is an essential material for the development of uh, for development of this nation. So cement is one of this major major this material for this development of nation. This world consumes around 4 billion tons of cement annually, but due to this COVID, it was badly affected supply chain, and this production also affected. So this cement industry, it contributes around 5.4% of this global gross domestic production, and around 7% this employment. But during this COVID, it has been affected. Next. This is the worldwide, what is the effect of this COVID. Mostly it is affected this Southwest Asia that demand declined more than 10%. So India also, it is more than 11% is got this affected during this COVID era. But this Commonwealth of Independent States, it is around 5%. Central and Eastern Europe around 4%, North America around 3%, Latin America around 6%, MENA area is around 7%. Was Sub-Saharan Africa, it was not that much affected. It was nil. Next. That post that COVID era, this the utilization of the project, the utilization of the capacity, it was around 70%. But after this COVID, the utilization of this plant capacity, it has come down, is around 60%. Due to this lockdown, this some of the companies, they have postponed their project. That ACC also, we understand, they have slashed down their project due to this COVID. So some companies who proposed for this expansion, they postponed it. So that is also major this breakdown for this COVID. Our last 12 months, this that share market also, this most of the cement companies share market also that's gone down, that 52-week low and high, it affected. Due to this COVID, these fluctuations of these foreign exchange rates, so it also affected much. Next. The COVID second wave also adversely affected this domestic cement production. Domestic cement production gone down around 12% year to year, but this quarter second and quarter three, it is improving, and which is driven by this rural, this housing sector, and some infrastructure. Government also trusted that infrastructural activities. So now we expect that demand will go up. The production of March 2021, it is around 33 million metric ton. Last year was also, it is around 2019, it was 33. So now it has come back. Next. That cost in the meantime, this due to this cost also, due to this price of this diesel, that logistic cost also has gone up, and this coal is one of the major inputs of the cement manufacturing. Now this coal price also gone around 2.5 times more So it is also affecting this production of this cement and the price of cement also. So all these things, this price of this coal and this price of diesel price, or logistic cost and production cost, this day by day it is going up. Next. That due to this COVID, these companies also answering some health and safety regulation which are imposed by government. This companies also adopted this all safety and this health regulations, environment, and all these things also. It is also affected. Next. These are this control manner we took up. This the most of the companies they have taken up during this COVID. But this Odisha grinding unit that we commissioned in August 2020. That means in COVID era. So that time this most of this labor also left. So, but we have somehow we have commissioned the plant and we have started production. These are the things in a nutshell. Thank you very much. Thank you.
Thank you so much, Mr. Paul. I think you have adopted to some of the best practices and the compliances which you're adhering to. I think everyone should look up to your company. And now I would request our next speaker, Mr. D.S. Malik, Director and HOD, Mechanical of DCPL, and address us.
Can you hear me?
Yes, sir. You're audible.
Yes. Can you please make the presentation on the screen?
Yes, sir, just a minute, I am sharing, sir.
Yes, sir.
Okay, you do. Good afternoon. First, I express my sincere thanks to ICC for giving this opportunity to speak in the midst of this August forum. I am Dipto Sundar Mullik. I am speaking from Development Consultants Private Limited, popularly known as DCPL. DCPL has been in the industry of consulting engineering for the last 70 years, 70. Although our flagship area is coal-fired thermal power station and gas-fired thermal plants, but we have also very strong presence in cement plants. We have worked in cement plants for the last 50 years. We have done about 400 assignments in cement industry. And our presence was there in India, in Asia, other Asian countries, in Latin America, and in Africa. So we have done a lot of cement plants. And today we'll speak about a topic which is waste heat recovery in cement plant. In the morning, we had talked about decarbonization, COP26 at Glasgow, where the consensus effort was that we should take up all the procedures so as to bring down the overall world temperature to a level of 1.5 degrees centigrade within this century, which is a very tough target. And to make that target, one of the possible ways is to tap all the decarbonization mechanisms in the cement industry, because cement industry contributes about 6 to 7% of greenhouse gas in the world. So it has its own role to play. And on these context, possibly in this the technology of taking advantage of the waste heat available is a good thing. Now let us see what happens. in a cement plant. In a cement plant, we apply heat for various purposes, particularly for calcination reaction to happen. And if you see see a pie chart, you will see that 58% of the energy is really spent for fruitful purposes, which cannot be avoided. And you see that 20% of energy is lost through preheater exhaust, and about 12% of energy is lost through cooler exhaust. There are other losses also, but those are insignificant, and those cannot be, those are unavoidable loss, we call it. But there are opportunities by which this 20 plus 12, 32% of energy can be explored and can be utilized for fruitful purpose. So that is the target of waste heat recovery in cement plant. Next, please. The amount of energy available for a 4-stage preheater is about 190 kilocalorie per kg. More number of stages means more heat transfer in the preheater, and therefore the less amount of heat liberated through the preheater. So 5-stage gives 165 kilocalorie per kg. 6-stage gives 140 kilocalorie per kg. And even this figure is quite high. Please, next one. And another area where you have a lot of hot exhaust gas is cooler. In cooler, the first generation cooler gives you 110 kilocalorie per kg, whereas the best coolers nowadays give 75 kilocalorie per kg. So that means from preheater and from cooler, you have sufficient amount of energy. Now, can we utilize it fully? No, it cannot be, because all of you know that in the preheater, the hot gases are also utilized for doing some useful purposes for drying the raw meal. Next, please. In the raw meal, you have in the raw meal, you need to dry it to about 1 to 1 point, dry limestone to 1 to 1.5% of moisture, and normally we get limestone with higher moisture, 3%, 4%, 5%. So that means you have to put sufficient amount of heat so that the moisture gets evaporated. So we have given a chart here that if corresponding to, say, 2% moisture, what is the amount of heat that is required, corresponding to 4%, etc. Next, please. This chart gives the entire thing in a very nutshell, that in the what is the heat requirement in raw meal, and we have given various charts corresponding to what is available corresponding to 2% moisture, 4% moisture, 8% moisture, and you can see that in say at 6,000 ton per day capacity, and if you have say around 4% of moisture, then about you need about 15 megacalorie per ton, megacalorie per hour of heat, which is actually required for useful purpose in the raw meal. So this we have to tap, and what happens that in spite of tapping this amount of energy, you still are left with sufficient amount of energy. We are coming to that. Next one, please. Here it gives a chart which shows that what is the amount of energy available in the preheater exhaust gases, and what is the amount of energy that is required for raw meal drying. And you see that if it is 2% moisture in limestone, then you have 140 kilocalorie per kg of heat available in the exhaust, whereas your requirement for drying is only 33. So you have about 107 kilocalorie per kg of heat available for doing some other useful purpose. And if the more the moisture, so naturally the more the amount of heat required in the raw meal, and so the availability of heat for useful purpose becomes lower and lower, and at about 10% moisture, possibly whatever heat is available in the preheater, that is completely taken care by raw mill. So you don't have anything in excess which can be utilized. And if the moisture content is more, in fact, you have to supply more heat from some other sources. So that is the situation. But in most of the cases, we are operating in a range of 3 to 4% of limestone. So that means we have plenty of heat. We have about, say, 100 kilocalorie per kg of heat available in the system for doing some useful purpose. Next, please. Also, some heat is required for additives, and this chart gives what is the amount of heat that is there. That is not very significant part. Next, please. Next, please. Now, can you just skip this one? We'll come back to this once again. Can you skip this one and go? This gives a chart that what is the amount of heat, what is the amount of electric energy that you can tap from your cement plant. It obviously, as I discussed, that one major factor is the moisture content in limestone. But generally, you can see that a rough thumb rule is, say, 25 kilowatt hour per ton of clinker to 45 kilowatt hour per ton of clinker. This is the range in which the energy, electrical energy, can be made available with our present technology. Now here you can very roughly I can give you a thumb rule sort of thing that per 1,000 tons per day you can get a power plant of 1 megawatt. That is, if you have 10,000 tons per day capacity, you can guess that you can get around 10 megawatt or a little higher, but that is the type which is available. Now one can wonder that if it has such a good opportunity of tapping energy, and if it has so many good features that 10 megawatt power is not a matter of joke. If it is there, then why it is not being applied everywhere across the country? It has been applied only in some selected plants, and my experience is that our company was involved in preparing TEFR for many plants. We have prepared the TEFR, and then it has been found that the customers, they decide, they fumble that whether to go for it or not to go for it. What are the reasons? There are technical barriers. There are financial barriers. The technical barriers is that here your waste gas has a lot of dust, both in the preheater, both from cooler. So, and these dusts, they foul the heat transfer areas very quickly. So whatever was your calculation that you will get so much of it extracted from flue gas, you are not getting that. So this is a challenge, and this challenge has been addressed, and gradually very good soot blowing systems have come up so that the efficiency of these boilers are very high, say more than 95% it has reached. But still you have to put some money to defoul the boiler heat transfer surfaces. So that has been a challenge. Number two challenge is, many speakers told that due to various factors, the cement plants are not operating at their full capacity. COVID is a big factor. And the moment your capacity comes down, the amount of gases come down, and therefore the amount of power you generate from your wasted plant also comes down. And the economy, whatever you had established or you had worked out, goes haywire. So the plants should operate at a fairly high loading factor. That's important. These are the technical barriers, but the more important thing is the financial barrier. We have worked out in the recent times that for a waste heat recovery plant, my cost is about 10 to 11 crores per megawatt. Compared to that, I am comparing that for a captive power plant, it is 5 to 6 crores per megawatt. Although for waste heat recovery plant, you don't have any fuel, but still what happens, because of the high capital cost involved, your payback is not very attractive. It is in the range of 7 to 8 years. And although it has a very good opportunity of decarbonization, but the investors, they also want to look at it from the business concept, that whether I get good revenue out of the investment, which still now is not operating. Unless some decarbonization factor, some prototype carbon fund, or some decarbonization fund is created, and that much of the decarbonization is given some credit in working out the payback, it's very difficult to compete with the investor's target of getting a payback within 4 or 5 years. Please, next one. Now, regarding technology, there are 3 technologies which are available to tap the waste heat energy. One is the age-old Rankine cycle. Okay, Rankine cycle is about 100 years old, and it is very, very mature, so we know about it. But since the temperature ranges are quite small, quite low, and therefore Rankine cycle has a poor efficiency, we have worked out that the cycle efficiency for a waste heat recovery plant is around 21–22%, because our steam temperature and pressure are quite low, has to be low, because the temperature potentials available from the sources means preheater exhaust or cooler exhaust, is quite low. From preheater, hardly we get to 80 degrees centigrade. From cooler, even if you take the mid-duct tapping, it's around 400 degrees centigrade or 405 degrees centigrade. So the maximum steam temperature you get is around 370, 380 degrees centigrade. And your pressure will be 17, 18, 20 kg per square centimeter. So we are left with an efficiency of hardly 21–22%. Compare this with our utility boilers, which have a pressure of 130 kg per square centimeter, which has a temperature of 540 degrees centigrade, and we get a reasonably good efficiency of say 35%. For supercritical, it is higher, even higher pressure and temperature, and higher efficiency of 42%. So 21% is an efficiency which is quite low. But again, one can argue that whatever we are getting, that is free. Other than the capital cost and a very small amount of maintenance cost, there is no fuel cost involved. That's true. But within this framework of temperature boundaries, there are other technologies which are also getting developed. One is, instead of using steam as a working fluid, we can use ORC, which is called organic Rankine cycle, with pentane as working fluid. There are quite a few plants, and a new Kalina cycle has also been developed, where ammonia is working as the working medium. There is one plant in Pakistan which is producing about 7 megawatt of waste heat recovery from Kalina. For just your information, within these temperature boundaries, ORC efficiency is about 35–36%, and with Kalina cycle, the efficiency will be around 60–65%. But again, both these technologies are still not in the mature stage. Rankine cycle has come to a stage after 100 years of operation, whereas these plants, these technologies are quite new, and it is being established. Also, the working mediums are not very friendly, either pentane or ammonia, none of them is friendly thing. So it is going through some process. Let us see that whether in later date these technologies get mature and we get more efficient power plants. Next one, please. This is what I just talked. Skip this and tell. Next one. This is the flow diagram, how it operates. Almost all of you are cement experts, so you know that in our country, it's through Rankine cycle. You get some heat from preheater exhaust gas. It is taken to a boiler. The boiler heats steam water and makes it into steam. In the same way from cooler, also you get steam. And beauty of this waste heat recovery plants is that you are getting energy from two different sources at two different temperatures, at two different quantities. So design of this waste heat recovery and making a mix of that does require some knowledge about heat transfer and thermal engineering. The companies who do this, like say Thermax or EastJEG in our company, or say Chinese companies, they have developed this technology. I can proudly say that in our company also we have developed an Excel-based program to find out that what can be the best optimum combination. You have some heat at some temperature, you have another heat at some temperature. So what can be the optimum temperature of the steam so that you get the maximum energy out of electrical energy, out of the heat energy that is available. That technology is mature and available. And one of the another very special feature of this turbine is that it's not the traditional turbine where steam enters and then exhaust gets out. We have this is an injection turbine where steam at various pressures, at 2 or sometimes 3 pressures, are injected into the turbine so as to get the best efficiency from the turbine. But whatever said and done, as I have told you, that you cannot beat the efficiency created by Rankines, and therefore the efficiency of 22-23% at this moment is the highest what we can reach within the temperature boundaries we are speaking. Next, please. This is a heat balance. I will not go through it seriously because it will take some time. Now here I am sharing one experience of a project which we did very recently. It is a plant at Maihar. Our LOI was given. LOI to us was given by Reliance Cement. Later, this was taken by Birla Cement. So we worked with Reliance Cement initially, then with Birla Cement later. The clinker production capacity was 10,000 tons per day. The heat number of preheater stages were 6. We had the feed gas available. We have given the figure 2 into 3,25,000 Nm³ per hour at 290 degree. Cooler gas 204,000 Nm³ per hour at 450 degrees centigrade. The beauty is that at pH boiler outlet temperature was 190 degrees centigrade, because that's what it was desired by the raw mill dryer plant. So here we are from the pH, we are getting a delta T of from 290 to 190, and which we can fruitfully utilize. And cooler outlet temperature, cooler doesn't have that much of, the outlet doesn't have that much of function to do. So we can reduce it to as much as low as possible. 100 degrees centigrade is the lower boundary. And the company who did this contracting company was Thermax Limited, and we got a power of 12 megawatt, and that has been operating for the last 2 years, I believe. Next, please. So in summary, I finish it up here that we have sufficient amount of it. We can utilize this. This can be a big step towards decarbonization in cement plant, but the investment return has to be a little more faster so that the entrepreneurs get tempted to install these plants, and therefore some decarbonization fund which the developed countries has announced in the last COP26 in Glasgow only in the last week, that there has to be some mechanism so that these cement plants, they get some money at a very short-term loan to install these plants, which ultimately will benefit everybody. So thank you very much for your attention. Mr. Chaudhary, please.
Yeah, thank you so much, Mr. Murlik. I think this was a wonderful presentation, and you have thrown some light on the technical part of it also, which I am sure everyone would appreciate. So as we come to the close of the summit, I would once again like to thank all our eminent speakers, our sponsors, participants, friends from media for being with us and supporting this initiative. With this, I would like to close this session now and look forward to see you all in the next edition, which is the 5th edition of Cementing India, and maybe in the physical form now. Thank you.
Okay.
Devu, you can close it now.
Okay.